Okay, one last thing. Let's try a challenge problem. This one's not super difficult, but it's a type that comes up fairly often, and it's a good way of kind of reviewing these two different types of sequences. And in typical fashion, I've chosen one where it's kind of backwards. We need to figure out the sequence based on a description of it. So the question asks us to find the value of x that makes this sequence okay, and the sequence is 4 for the first term, x for the second term, and 3/2 x for the third term. We're going to do two different things here. For part A, we'll make the sequence arithmetic. And for part B, we'll make the sequence geometric. So don't worry about part B yet. For part A, what we need to catch is that if it's arithmetic, then all the terms differ by the same amount. So to get from 4 to x, you would add whatever the d value is. To get from x to 3/2 x, you would add the exact same thing. So d has to equal this gap, and it also has to equal this gap. You could set up a system of equations here, but really all we need to do is to make the difference of the terms be the same. If we take term 2 and subtract term 1, that's got to give the same thing as term 3 minus term 2. The reason those have to be the same is that they're both equal to d, which is the common difference. So substituting in the values here, we get that x minus 4 equals 3/2 x minus x. I've just taken a term minus the one before it, and another term minus the one before it. Those differences must be the same. Well, so now we've got a nice little linear equation. It's not too bad. We have a fraction, but it's going to go away. At this step, we'll just multiply everything by 2, and we get that x equals 8. You can check that by then figuring out what the sequence would be. Our first term was 4. Our second is x, which is 8. The third term is 3/2 of 8, which would be 12. And yeah, this is definitely arithmetic. Plus 4, plus 4. So that works. For part B, we're asked to make the sequence geometric. Well, same idea regarding the gaps between the terms, except that this time instead of adding the same thing, we need to make it to where we're multiplying the same thing. Well, so what that means is that if you take a term divided by the one in front of it, it's got to equal any other term divided by the one in front of it. Substituting in these values, we get 3/2 of x over x, term 3 divided by term 2, equals term 2, which is x, divided by term 1, which is 4. Again, the equation's not too bad to solve because these guys are going to cancel each other out. So we get 3/2 equals x over 4. You can cross multiply to get that 2x is 12. So therefore, x is 6. And once more, let's just take a second to check and be sure that really does make the sequence geometric. Well, if x is 6, then the sequence up here becomes 4, 6, and 3/2 of 6 is 9. So 4 times 3/2 makes 6, and 6 times 3/2 makes 9, which means yes, we have a geometric sequence with an r value of 3/2. All right, so now that you've watched these two videos, go and see if you can solve the practice problems. There's a link on the website. If you're having trouble, look back at the two lessons in the textbook that I've referenced here, 6A and 6B. You'll find definitions, you'll find a few more examples, but that might be helpful. And we'll talk about all of this more when I'm back. And then we'll move on to more complicated things actually beyond that. We'll look more at specific properties of arithmetic sequences and geometric sequences, and then on to series beyond that. All right, that's all for today. Have a nice one.